So real quick recap what I said before I start the recording. Today we're learning how to write equations of circles where we can readily see the center of the circle and we can readily see the length of the radius, or easily be able to find the length of the radius. Just like in slope-intercept form up there on the right whiteboard up there, y equals mx plus b. In that form, if you'll see that example, y equals 3 times x plus 2, we know the y-intercept is 2, and we know the slope is 3, right? So in the equations, we are going to write using the center point and the radius, or given the equation, we'll be able to give the center point and the radius quite easily. So the form for the equation of the circle is x minus h all squared, where h is the x-coordinate of the circle, center of the circle. So remember, the center of a circle is a point. So when we discuss it, it's an ordered pair, right? It's got an x-coordinate and a y-coordinate on the coordinate plane. So it's x minus h all squared plus y minus k all squared, where k is that y-coordinate of the center of the circle. Sometimes you'll see this written as x1 and y1, but the more standard way is that hk. And then it's equal to the radius squared, okay? Where r is the radius. All right. So I don't know if you guys remember point-slope form. It's y minus y equals the slope times x minus x. That was the one that when you plug in a point, it looks like it's going to be a positive coordinate, and it's a negative because the standard of the equation is a minus. So I'm not sure if that description was very helpful, so let's just jump into here. Maybe. Okay. So looking at this equation, this is the equation of a circle, right? So the form is x minus the x-coordinate. So since this is still a minus 5, we know that actually the x-coordinate of the center point is a positive 5. If it were a negative 5, that would not be minus 5, right? That would be plus 5. Just so here, y plus 4, well, if this is the equation of the circle, the y-coordinate has to be a negative because that's the only way there would be a plus in that second binomial, right? So the y-coordinate for the center point is actually negative 4. When you plug negative of 4 in here, it's minus a negative, which is actually a positive, right? And now, since this is the radius squared, how can we find the radius? Just take the square root, right? So the square root of 25 is 5 and negative 5, but remember the radius, we're talking about the length of the radius. The length is always positive, so we don't worry about the negative square root. Okay, can anybody tell me what the center point of example 2 is? What is the center point of example 2? Can you tell me, Ibrielle?
-1 and positive.
Perfect. That's exactly right. The only way to get that +1 there is if that were a -1. Nice. And what is the radius of that circle? Darren, can you tell me what the radius of that circle is? Perfect. The square root of 400 is 20. Easy peasy. Now this one doesn't look right. Right. So think about it a minute. How could we go from this form of equation and wind up with only an x squared or a y squared? What must we plug in for h and k for it to simplify to x squared? 0, right? So 0 for each of them, which means if you see the equation of a circle and it looks like that, that means it's going through the origin, right? I mean, the center is the origin, right? So just so you can see what that looks like, if it was x minus 0 squared plus y minus 0 squared equals 81, we would simplify that. I don't know why they choose to simplify it there when they don't on others. It is kind of like the point slope form. We can do the same thing, right? That right side or the left side. If those coordinates in point slope form for a linear equation were 0, we always simplified that side. Just down to the x or y. So, if you see the equation of a circle that looks like that, we have to know that that means the center is at the origin. And so what is the radius, the length of the radius for this circle, Thomas?
No.
What's the length of the radius for example 3? From this equation we can tell.
9.
Perfect. Any questions for me? Okay. All right, so one of the things you're going to have to do on Alex is graph the circle given the equation. And really, all you're going to need to do is plot the radius, well, identify the radius, identify the center point, and graph them. And I'm going to show you how to do that. Can you tell me what the radius of this circle is, Tori? An example 4? Yes, very good. So the length of the radius is 2. What is the center point? So remember, at the standard form of that equation of a circle is the radius squared, right? So if they tell us that the radius squared is 25, we take the square root of 25. All right, so look up here. So we know that that radius is 5 because the square root of 25 is 5. We know this radius is 20 because the square root of 400 is 20. This one is 9 because the square root of 81 is 9. Okay? All right, and then what is the center of this circle? Vivian, can you give me the center of the circle? Perfect. All right, so then we're just going to plot the center point. So the center point is 4, -3, so from the origin, right 4 and down 1, 2, 3. And then you've got a circle that you're going to drag on Alex, and you can expand it proportionally or shrink it proportionally. So when I did it, I just plotted vertical radiuses and the horizontal. So I went right 2, I went up 2, I went left 2, and then I went down 2. And then when I drag my circle over, it was easy to just align it with those points. So I think this doesn't work exactly like mine expands, but pretty close. So then you can see, then you can just expand the circle so it lines up with your 4 points which you marked for the length of the radius. Does that make sense? Okay. So when y'all have any questions? Y'all got me? You're all good here? You are going to draw by hand on this paper, but you're not going to have to draw that circle by hand on the assignment. Example 5 says, given the equation of the circle centered at the origin, so we need to know that that means the center point is 0, 0, right? Given that, with a radius of 8. Oh no, they want us to give the equation of a circle that center is at the origin and has a radius of 8. So I think the easiest way to do this one is just, the way to explain this one is to show it to you on a coordinate plane. If it's at the origin, it's just going to be the distance from the origin, which, remember, if the origin is the center, that's the radius, right? The radius is the distance from the center of the circle. So, it's not working very well. Okay. So if I have the origin, our coordinate plane, I do not want yellow, and I cannot get yellow off for some reason. to the origin right there. And so we know that's the center of the circle, and we know that the circle goes to the point 0, 8. So over none, and that's 1, 2, 3, 4, 5, 6, 7, 8. So we know the circle goes through there. I'm not going to draw the whole thing. So how long is that radius? That is the radius, right? Does that make sense? So from this point to this point is the radius. How long is that radius? Just 8, right? If it's at the origin, you can just subtract, I mean, it's just whatever the y coordinate is, or whatever the x coordinate is, right? They could give you 8, 0, and it would be the same thing, right? So over 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 0, that's the same length radius. Does that make sense, Charlie? No? Yes? Annalie, does that make sense? Okay, so, I lied. I'm doing a wrong problem. They just give you the radius. Ms. Zimmerman is trying to make things way too hard right now. We do have a problem where we have to find the length of the radius when they tell us that, but this is not that problem. Okay. Mighty dog. All right, so that's what we're going to plug in. Plug in the center and the radius, and then just simplify. We'll get out of here at 11:55, just so everyone knows. All right, any questions? Okay. This is the one. So instead of 0, 8, 0, 9. So give the equation of the circle centered at the origin passing to the point 0, 9. Well, if the center is at the origin and it goes to the point 0, 9, we know the radius is 9. I already showed you that example. Does that make sense? So now we just plug it in again. We have to remember it's x minus the x coordinate of the center plus y minus the y coordinate of the center equal to the radius squared. And that's going to simplify to x squared. We're not going to leave the 0 in there. Plus y squared equals 81. So the only time we do that is if that point is 0, 0. And the other time we couldn't simplify it, right? I guess the only reason why we simplify it is because that's the only thing we can simplify it with. If it were any other constant, there's not an equivalent to simplify it to. All right, so here they give us the radius, and we're going to write an equation of a circle with this as the center. So everybody, this is what we're filling in, right? Now, I've got bad news. Bad news is this formula is not on the reference sheet, which means you have to remember it. Okay? Oh, I don't want the R. So we're going to go ahead and plug in. So x coordinate, y coordinate, but remember we call this the h and the k in this formula. So it's going to be -7 here, -2 here, and here they give us the diameter. We can't plug the diameter in. We have to plug the radius in. So if we know the diameter is 10, can we find the radius? What's the radius? Analia? 5. How do you get that? You divide it by 2. So the radius is the diameter divided by 2. So the radius here is 10 divided by 2, or 5. So now we're going to put 5 in there. And now we're going to simplify, which really just means if it's a minus and negative, we're going to change that to a plus, and we're going to square the radius. So our final answer is x plus 7 all squared plus y plus 2 all squared equals 25. questions? Did I skip one? Let's go back up. I see that I did now. All right, you guys see that one? Fill in the blanks. I'll give them to you. All right, what'd you plug in? Swan, what'd you plug in here? Okay, yeah, so you only put 0 if this says with the center at the origin. All right, so what did you plug into this first spot, Harlan? Yes, -6, good. And what did you plug in here to Corey? Perfect. What did you plug in here, Mayal? Oh, no. So this one is different, right? This is, they gave the radius. This one is the diameter. So this one starts with an R, so we don't have to do anything with it. Yes, 12. So now we just got to simplify the minus the negative, so plus 6 squared plus y plus 8 squared equals 144. And that's what we type in, okay? The only time we put the zeros in is origin. Any questions? Okay. Find the equation of a circle that has center -3, 3, and passes through point -1, -5. I have a feeling maybe, well, I'll just talk you through both ways. All right, so we know this is the standard form of that circle, of the equation of a circle. X minus h all squared plus y minus k all squared equals the radius squared, right? So here we do have the center, so we can plug that in. But they gave us the point that it went through. They did not tell us how long the radius is or the diameter is, right? So what are some ways that we could find the length of the radius? Well, remember the radius is the distance from the center to the circle. So there are two ways that I can think of. One way that pops into my mind that I like better, but we have really been focusing on the Pythagorean theorem. So I'm going to show you that way, and then I'm going to show you how to find it using the distance formula, because we've practiced using the distance formula a lot, and the distance formula is on your reference sheet, right? So I'm going to show you both ways. Is everybody caught up with me? Okay. So let me, all right, so that the center point is -3, 3. So -1, 2, 3, up 3. And the other point, is it negative, what's the other point? -1, -1, -5? Okay. -1, -1, 2, 3, 4, 5. All right, so this is the center point. I'm going to call it C. Well, we need to know what is the distance from here to here, because that would be the radius, right? So there's a couple of ways there's two ways that I can think, I'm sure there's more than that. One way is to use the Pythagorean theorem. So we could sketch a right triangle, a squared plus b squared equals c squared. So you can count the a, you can count the b, and then plug it into that formula. When I filled in my notes to teach the other day, the thing that I thought of was the distance formula. I don't know that one is any easier than the other. We are going to be talking next about the Pythagorean theorem and how it relates to deriving that equation of the circle, but there's always a bunch of different ways, well, several different ways at least, to solve most of the problems we do. So I was going to show you the other way. So we could use, that would be 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, and then use Pythagorean theorem. But the way that popped into my mind was just to use the distance formula. So remember, the distance formula is x minus x plus y minus y. And if you forget the distance formula, go here, click on our reference sheet, and that you're going to have that on the test, right? So radius is the distance from the center to the circle. So it makes sense to me that we just use the distance formula. But either way works, okay? So it would be the distance from this point to this point. From this point to this point. X minus x plus y minus y. Right? Now here's the thing. It's an irrational number. They won't always be, but sometimes they will be. We do not want to round that number. We're going to leave it as a square root. And I'm going to show you why. So now we know that that is not only the distance from the center, but that is the radius, right? So now we know what the radius is. So now we're going to take what we've already plugged in there, and we're going to simplify that to x plus 3 squared plus y minus 3 squared equals our radius squared. That looks pretty ugly, but what happens when you square a square root? Yeah, you get the number under the radical, right? So if we find the square root of 68 squared, it's just 68. But you can do that on your calculator. So press 68 square root, 68 square root, and then hit x squared, and you see you get 68. So that's going to simplify to just x squared plus y minus 3 squared equals 68. So Pythagorean theorem, if you feel more comfortable with that, or the distance formula, if you feel more comfortable with that. I don't think anyone is less work than the other one, but I don't know. Any questions? Got caught up? All right. And is this the last one? Okay. So we can model the equation of a circle, or probably they would say show how it's derived by a question like this and using the Pythagorean theorem. So I don't know, I'm going to make this a little bit bigger. As you can see, so this is a circle. Its center is point P. They've labeled the radius of this circle from point P to a point on the circle. Now, we don't know what that point is because it's not where any grids, any cross, right? So it's not a number that we can look at the graph and identify that point, okay? But we know the length is 2, all right? If we identify the center, hopefully everybody knows that this is the center point here. So to give that ordered pair, start at the origin, count over to you're even with that point. So right 3 is a positive 3. And then from there we go up 5. So the center point is 3, 5. I feel confident that most of you know that, if not all. We did not have to figure out the radius. They have it labeled for us. It's 2 units, right? So if we don't know what this point is, which would be the end point here that shows us the radius, right? And we don't, we can figure out what that point is using some of the strategies, but they want us to model this equation using the Pythagorean theorem. So the first thing we have to do is we have to write this distance. Let's see if I can use my pen. I know I'll use that now. So we want to model first. We're going to write the value of A in terms of X here. Means we want to give, so the value of A is this length. Does that make sense? That's what A is. So that's this side of a right triangle that they have sketched in this circle from the end point of the radius that's given horizontally to the center point so they can create a right triangle. Okay? So the question is to give the value of A in terms of X. Well, we don't know how long A is, but we do know that from the y-axis to here is 3, right? So we need, and we know it's 3 plus A, or we could say that A is X minus this 3. So really, to make it easy for you, it's the X. So if we're giving the value of A in terms of X, it's X minus the X coordinate at the center point. Okay? Now, if we want to give, when it says in terms of X, that means we're explaining it by using X. Okay? So the X coordinate. So if we're giving the value of B, well, B is the distance from that right angle vertex up to that end point where we sketch that other leg of the right triangle. And we know, we don't know that length, but we know that it's 6, well, this is 6 units from, no, it's not 6 units. We don't know how far it is. This would be 6, right? But we know from here to here is 5 units, right? We're going up 5. So if this is in terms of y, it's the y coordinate minus the y coordinate, basically. So it's y minus the y coordinate. So if we give this length, side length in terms of x, it's the x is minus 3, x minus 3. And in terms of for b, the vertical side length is going to, in terms of y, would be y minus the y coordinate at the center point. So why do we do that? Once again, they want us to model or show how that equation was derived, I think. So we can use the Pythagorean theorem, which we all know, is a squared plus b squared equals c squared. I don't think that's in your notes. You're going to sketch that above your, somewhere below b, between the answer boxes. So a squared, if this is a, right, well, that's a squared. We're just substituting into that Pythagorean theorem the value that the other way to write a, right? The other way to write b and then the radius, if you'll notice, the radius is the hypotenuse of that triangle, right? The side across from the right angle. So the radius is 2 squared. So we're going to simplify that is y minus 3 squared plus y minus 5 squared equals 4. Yes, I did. Thank you. I meant x. Any questions? Okay. Make sure when you get to that question, you go back to your notes. Okay. The horizontal would be the terms of x, the vertical the terms of y. X-axis is horizontal, y-axis is vertical. We still have a few minutes, so we're going to actually just start our homework. We're not going to scan and submit because we get out of here at 11:55. So we have a little less than 10 minutes. You can work on your assignment, and you can scan and submit at the end of class.